Good evening, everyone. Now I am going to take the interview of the Ahmed Sheesh. I will ask the questions in first section, then I will give the feedback in the later part. Okay, Ahmed Sheesh, can you introduce yourself?
Yes, sir.
Uh,
So my name is Ahmed Chishtava. I am from Kerala, Kasaragod district. I have completed my schooling in Prestige International School and I have batch marks of 9.4 CGPA. I have completed my secondary PU education in Karnataka Board of Education in Mangalore. I have secured marks of 76 percentage. I have completed my BE in Mechanical Engineering from VTU University. I have batched marks of 82 percentage aggregate. Speaking about my family, I have my father who is a businessman. My mother is a teacher, and a sister of studying in eighth standard. Speaking about my strengths and weaknesses, I have always been a self-motivated and a hardworking student. I know my responsibilities and I know how to take care of any situation which is going out of my hand. I would like to tell you that whatever I have captained in many teams in my college and school. I was a captain of my kabaddi team, so I know how to lead the team. And whenever the team is about to lose, or whenever the situation is going out of my hand, I know how to control this. So that
hmm. When did you pass out?
this year, sir.
Okay. Okay, let me ask the technical questions. Can you draw the centrifugal pump and explain how the discharge pressure is created? Okay, please draw the centrifugal pump.
Ash-
Hmm. See, section pipe. You didn't mention the this one strainer at the suction pipe end,
uh,
and
Trainer and footwall.
wait, impeller, eye of an impeller, impeller, discharge pipe, discharge valve. It's fine, it's correct. And little when you are drawing that at the impeller ka outside ka casing is there, no, that one you little you can see it, means like little proper you can draw it. And so that is the
Okay.
important point, because first the volume will be less, means like first the area
Okay.
of that is there, no, you should decrease and then you go on increasing at the towards the discharge side. So that is how it is volute casing, no, so you check it once, only that part.
Okay.
Other than that, the direction of the water, it's everything is fine. Okay, can you explain how the pressure is created at the discharge side?
The pressure is created at the discharge side due to the centrifugal force, because it is a rotary because it is a rotodynamic type of pump. So the centrifugal principle acts when the impeller rotates. The water inside the casing, that is the water inside the casing, gets displaced radially outwards towards the discharge, and the pressure is builded at the discharge discharge side of the discharge side of the centrifugal pump. That is how the discharge pressure is created.
Okay, I will give the feedback at the end of these questions. Okay, then second question is, can you do the gear pump and explain the working of it? Can you draw the gear pump? X, 1 second. Uh, Casing, driver. One is follower, another one is driver, and you didn't mention the pressure relief valve. Pressure relief valve, it connects the discharge side and the inlet side of this pipe. Yeah, so you have to mention it. Okay.
Where I'll have to do that?
From the discharge pipe to suction pipe is there, no, there. I will send you the notes. I have already sent you. You can see it over there. Means
Okay.
and even if you Google also you can get this one. So diagram is not that up to mark. Can you explain the working of the gear pump?
So the main components in the gear pumps are inside the airtight casing. There are two gears. That is, one is driven gear, one is a driver gear.
Hmm.
The driven gear is connected to a externally linked electric motor which drives the which drives this gear. This gear is intermeshed or interlocked with the driver gear. This when the driven gear rotates in one direction, the driven gear rotates in a opposite direction. And when these gears rotate, a suction is created from the suction is created from the inlet suction side, because of the vacuum present in at the vacuum created at the inlet side. The liquid gets sucked through the inlet side, and the liquid gets trapped inside the slots of the gear housing. And then as the gears rotate, this liquid is forcibly pushed towards the discharge side, which causes the discharge of the high pressure liquid. In gear pumps, the pressure is high and the uh, flow is constant.
Hmm. Flow is constant because of positive principle. Okay. Then
I
next
can't hear
question.
you, sir.
Oh,
I
sorry.
can't hear you.
Yeah, flow
Ah,
is constant because of positive displacement principle, and in a discharge side when it goes, no, there will be a pressure relief valve. So it will check the pressure. If the pressure is more than the desired one, then it will be released, and then other working I will tell at the last feedback. And VCRS, can you explain the working
yes.
vapor compression cycle? Yeah, tell me.
First, I'll tell the components.
Okay, okay.
For VCR, the components used in the VCRS cycle are: first, it's a evaporator.
Hmm.
From the evaporator, the low pressure, low temperature vapor refrigerant is passed to the compressor as a dry saturated vapor. This dry saturated vapor is fed into the compressor. In compressor, the low pressure, low temperature vapor refrigerant is converted into high pressure, high temperature superheated vapor, which is then fed into the condensers. In condenser, there is a continuous flowing of
Hmm.
seawater on board, and normal water on normal applications,
Hmm.
which helps in providing the cooling effect to the vapor. And it also has one important property, that is changing of the phase of the vapor into the liquid form,
Hmm.
liquid refrigerant. Therefore, now the refrigerant is in the liquid form, that is high temperature, high pressure liquid form. This is then fed into the collecting chamber, where this refrigerant is collected and is supplied to the thermal expansion wall whenever the cooling effect is required. In thermal expansion wall, there is a orifice fitted, on which reduces the pressure of the liquid refrigerant. As the pressure reduces, temperature is also reduces. And after the thermal expansion wall, it is then fed into the temperature. In thermal expansion wall, the superheat of 3 to 8 degrees are maintained. More the superheat, the lesser the efficiency of the refrigeration cycle. Then this low pressure, low temperature vapor refrigerant is then fed into the evaporator. In evaporator, the evaporator coils help into converting the vapor into the liquid state.
Hmm. And I didn't get what
Other
is that superheated thing you told? I didn't get it. What that superheat? Where?
In thermal expansion valve, the superheated temperature is maintained at 3 to 8 degrees Celsius. That
Superheated?
is,
No, it's
eh,
wrong. It's completely wrong. How the superheated? See, when it comes out of the condenser, it is already converted to saturated liquid. Okay. Then it will goes to the dryer. In the dryer, there will be a silica gel. Silica gel, means like it will absorb the moisture. Even in bags also
moisture.
they will give, it will absorb the moisture
Yeah.
content if it is present in the
Okay.
refrigerant. Then it will goes to the thermostatic expansion valve. In the thermostatic expansion valve, the orifice will be there. Then the saturated liquid is converted to saturated liquid plus vapor refrigerant. Then it is fed to
Mixture of
the then it is fed to the evaporator. There is no where the how to draw the pH curve. This one pressure, this enthalpy, the temperature curve is there. You know that pH curve, pressure enthalpy curve, that one.
uh,
Uh,
something like
okay, yeah, yeah. This one in the VCRS it will be there, right? like that only, but yeah, in that, so in the didn't review the dome of that.
Uh,
Okay, when the if you see it, no, there will be a saturated liquid plus vapor refrigerant will be there.
uh,
There is no you should not tell
mixture.
the superheated, so that is extremely wrong, so I am telling now only.
Okay.
Then
Okay.
after it goes to the evaporator, no, it will there will then it will go to the saturated vapor. Okay, in that saturated vapor, it is converted to saturated vapor. Refrigerant is saturated liquid plus vapor refrigerant is converted to the saturated vapor
Saturated vapor.
refrigerant. So there, if you maintain the superheat, no, in the because we will maintain in some in the industrial application, we will maintain the superheated vapor 2 to 3 degree, because it will increase the efficiency of the VCRS cycle in that.
Uh, so
So
superheat will be in evaporator, not in thermal expansion.
no, there is no chance of thermo expansion. You are only telling that the temperature will be reduced and it is
Okay.
converted to saturated liquid. Then how it will go to super? In the if you see the pH diagram, no, you will get to understand. Okay.
Okay.
Yeah, in the pH diagram, in saturated liquid side only, that line will be coming isenthalpic curve. It is called as.
Okay.
So it is a straight line at the saturated liquid plus vapor. Superheated is at the right side. No, after evaporator, there is a chance of superheated vapor to become. Refrigerant can become superheated vapor. So that
After
is the thing.
evaporator.
That is the thing. And you didn't told anything about the sensing bulb.
Sensing bulb. Sensing bulb, when the refrigerant passes after in the vapor form after the evaporator,
Hmm.
the sensing bulb senses if the temperature of the refrigerant is more than the desired value.
Hmm.
It will sense and send a signal to the thermal expansion wall to regulate the orifice opening,
With the
so
help
that
of capillary tube. With the help of capillary
with the
tube.
help of capillary tube
It
to
will sense. It will send the signal to the thermostatic expansion valves. Okay.
thermostatic
Okay. Continue.
uh, to regulate the opening of the orifice.
Huh.
Hence, when the orifice diameter increases, the temperature of the refrigerant will decrease because of the will decrease. When the orifice opening will decrease, the temperature will increase of the liquid refrigerant, liquid vapor mixture refrigerant.
Hmm. Okay, I will tell entire working after in the feedback session. Once I will tell everything, you can note it down.
Okay.
Okay. Then did you what is the temperature of the evaporator at the domestic refrigerator, for the domestic refrigerator?
In the freezer side of it mainly depends upon the type of refrigerant that is used.
Hmm.
But in common, when R134A refrigerant is used, that is
Hmm.
uh, hydrofluorocarbon,
Hmm.
the temperature roughly in the freezer is at around -18 to -20 degree
Hmm.
Celsius,
Hmm.
and in the uh, below section, that is normal freezer, it is around -3 to 8 degrees Celsius.
Hmm. Okay. Are you sure about these values, right?
Yes, I got to know from
Huh. Okay,
uh,
then if it is if you are sure, no, then only mention the values. Yeah, ऐसे तुक्का मत लगाना बस. Means like don't
uh,
okay.
okay.
Then what can you explain boiler mountings? Which are list the boiler mountings.
Some of the boiler mountings are pressure gauge, water level indicator,
Hmm.
pressure gauge, water level indicator,
Hmm.
fusible plug, blow off cock, feed check valve,
Hmm.
uh, air, air vent cock,
Hmm.
cum valve,
Hmm.
steam stop valve,
Hmm.
safety valve.
Hmm. Total there are 9. It is there. The first one is safety valve, gauge glass, feed chuck valve, stream pressure gauge, boiler blow down valve, and scum valve, steam stop valve, low water level shutdown, and Ventcock. These are the total 9.
So,
Okay. How many you told? Means like you
I
missed
told
something. Some, I guess.
blow off cock, I miss.
Ventcock you told.
Ventcock I told.
Okay, blow off cock you missed, no? Okay, okay, fine. And what is the function of your fusible plug?
When the water level in the boiler is below the minimum level,
Huh.
the fire will be put off.
Yeah, you are correct.
Using
When the water is below the required level, no, when the fusible
minimum.
plug is exposed, no, because of the high temperature, the fusible plug will melt down. So that is the
Also.
function. Okay. Then
When
yeah, tell me, tell me.
when it melts down, the operation will be stopped. Like
Operation will be stopped.
fire.
Yeah, that is the main thing. Then Faraday's law, you know, two Faraday's law.
Faraday's first law states that conductor is placed in a when a conductor is placed in a magnetic field. Sir, I don't know that properly.
Okay, okay.
I'll study that. I'll two questions tomorrow. Lenz law and
Okay,
Faraday's.
okay. Magnetic field links with a circuit changes. EMF will be induced. Means circuit changes means see the means like there will be two magnets. See this is magnet. This hand is magnet and this is a circuit. Okay. So magnetic field will be there. Here one magnet, here one magnet. Okay, like this. Whenever this circuit will cuts the magnetic field. Okay, if this circuit is rotates, if this magnetic field will cuts, right, whenever magnetic field is cutted by the circuit, then there will be EMF will be induced in the circuit. Okay, this is the first law. And induced EMF is directly proportional to the rate of change of magnetic field. Means rate of change of magnetic field means how much speed this will rotates, no, it depends on that. Means like EMF is depends on that. You can prepare tomorrow. This is the basic. Okay.
Faraday's second law is induced EMF in a coil is directly proportional to rate of change of flux.
Rate of change of magnetic field, like that. Okay, I will send you that. I will send my notes and you can see it. Understood, no? Means like this.
Okay.
Okay. Then you know the safety devices of the refrigerator? Refrigeration safety devices. Yeah, tell me.
The safety devices used in the refrigerator are LP cutout, HP cutout, low pressure, low boil cutout, bursting disc used in between the intake and exhaust manifold, bursting disc placed in a compressor, fuel oil heater, solenoid valve, relief valve.
Yeah, this much only. Then you know auxiliary engine safety devices?
Yes.
Tell me.
The safety engines used in the auxiliary engines are high temperature jacket water trip, high speed motor trip, high temperature exhaust gas trip, crankcase oil trip, high temperature crankcase trip. One I forgot.
Yeah, there are only 5 it is there. Okay, first is overspeed trip, jacket water high temperature alarm and trip, and lube oil low pressure alarm and trip. Lube oil if lube oil gets below the means how much ever is required value, no, then there will be an alarm. Okay, crankcase relief valve and high exhaust gas temperature. So these are the 5, only 5 it is there. And difference between 4-stroke and 2-stroke, you know? Yeah, tell me.
In two-stroke engines, for one power stroke, the revolution takes place are a single. If in two-stroke engines, for one power stroke, the two revolutions of the crankshaft is required. Or two revolution of a power stroke is required. In two-stroke engines, the inlet and exhaust of the fuel is taken place using the ports. In four-stroke engine, inlet and exhaust of the fuel are taken place using the valves. In two-stroke engines, the flywheel used is smaller because of less vibration takes place inside the two-stroke engines. In four-stroke engine, heavier flywheel are used. In two-stroke engine, the building of a engine is less expensive
Hmm.
than the four-stroke engine.
Hmm.
In two-stroke engines, the power generated is more.
Hmm.
In four-stroke engine, the power generated is comparatively lesser than the two-stroke engine.
Hmm.
The two-stroke engines have a high two-stroke engines are two-stroke engines produce larger exhaust gases
Hmm.
than the four-stroke engine. Two-stroke engines have a higher thermal efficient have lower thermal efficiency.
Hmm.
Four-stroke engine have higher thermal efficiency. In two-stroke engine, the volumetric efficiency is low. In four-stroke engine, volumetric efficiency is high.
Hmm. That exhaust
Fuel
gas,
used
how exhaust gas is higher, that is very wrong. You need not to mention that. In two stroke there is an high exhaust gas. You told, no?
uh,
No, that is not required. Don't tell
okay.
that. And
In two-stroke engine, the length of the stroke is length of the stroke is high. In
hmm.
four-stroke engine, length of the stroke is less.
Hmm.
Two-stroke engines can use low-grade fuel oils,
Hmm. Hmm.
and in four-stroke engine, the fuel oil should be of high grade.
Hmm. Hmm. Yeah, other thing is a proper. Yeah, and power to weight ratio of the two stroke is greater than the four
Four-stroke engine
stroke.
greater than
So that
power
also
to
you
weight.
can tell. And and this one, means like why four stroke is used as an auxiliary engine.
Four-stroke is used in the auxiliary engine rather than two-stroke because in four-stroke engine uh, in four-stroke engine is a unidirectional engine and it requires less oil consumption than the two-stroke engine.
No, actually, it's not the right thing. Means auxiliary engine means, see, there are two types of engine, if you know. There one is main engine, another one is an auxiliary engine. Main engine we use the two stroke because the power which we generate in the two stroke is very high. So because of that we will use it as a main engine. Four stroke, yeah, we use it as an auxiliary engine because relative, compared to the four stroke, compared to the two stroke, four stroke has a lesser power, and this auxiliary engine, see, there are, means like running of the ship needs the more power than the means generating the light and other thing, right, inside the ship. There means like other miscellaneous uses, we will use for use we will use the four stroke engine, and the frequency to which to run these electricities, which is generated by the four stroke engine. Okay, frequency which we want is a 60 hertz. So we will use one formula that the number of poles of the stator, means, yeah, it is there in my book, say, in that, why I have sent you the PDF, no, in that it is there, means like I mentioned it. Just remember that the frequency which is used to run the auxiliary engine is got by the four stroke, that is a 60 hertz. So because of that we will use the four stroke as a auxiliary engine, and two stroke generate a more power, right? So it is very helpful to run the ships. So this is the this
So
like this you can say.
that much power is not required in the for
Yeah,
auxiliary engine to produce power.
yeah. That much power is not required. So that is the reason. And you cannot say like an fuel which will use the high grade because of that. No, for both the auxiliary and main engine, same type of fuel only we will use. But the power generation is differs, no. So the power generation, how much we required in a for to run auxiliary engine is got by the four stroke. So because of that we will use. Okay.
Okay.
And then Bernoulli's principle, Archimedes principle.
Yes.
Yeah, tell me.
Archimedes principle states that when a body is wholly or partially immersed in a fluid,
Hmm.
the body tends to be lifted up by a upward force which is equal to the weight of the fluid displaced.
Huh.
This upward force is called as uh,
Buoyant force.
buoyancy. Buoyancy.
Huh.
Then Bernoulli's principle states that the incompressible fluid moving in a continuous stream,
Hmm.
uh, the energy remains same when the fluid moves from one point to the other.
Hmm. What all the energies? Pressure energy, kinetic energy.
Pressure energy, kinetic energy, and potential energy.
Hmm. Yes. And assumption, Bernoulli's principle का assumption, body has to
I
be,
don't know.
that one you see it, but body has to be the in viscous fluid. Okay. And
In viscous fluid.
in viscous fluid, that is the main. In viscous, incompressible fluid, incompressible, compressible, Bernoulli's principle, it doesn't matter,
I said
but in viscid, and there are some other assumptions. Okay, you just check it out. And what are the laws of thermodynamics?
laws of the zeroth law of thermodynamics states that when two bodies are in thermal equilibrium with the third body, then the bodies are in thermal equilibrium with each other.
Hmm.
One example of zeroth law is a cup of tea and the surrounding.
Hmm. Hmm.
The first law of thermodynamics states that energy can neither be created nor be destroyed.
Hmm. Hmm.
It can be explained by the example of a rubber band.
Hmm. Hmm.
Second law of thermodynamics, two people have stated second law of thermodynamics, uh, Clausius statement and Kelvin statement. Clausius statement states that it is impossible to transfer heat from the cold body to hot body. It is impossible without the help of external agency.
Hmm. Hmm.
According to the Kelvin Planck statement, it is impossible to construct a heat engine whose sole purpose is to change heat into work.
Hmm. Hmm.
Example of second law of thermodynamics is heat pump, heat engine, refrigerator.
Hmm.
Third
Hmm.
law of thermodynamics states that the entropy of a system, the entropy of the system becomes constant when the temperature reduces to zero.
Entropy is going to be zero. Change delta S is equal to zero, right? Means like absolute 0 degree temperature is impossible to achieve. Yeah. Whenever the absolute zero temperature reaches to absolute zero, the entropy will be it will cease. Means like everything will cease. Entropy will be zero actually. So change in entropy not. Entropy will becomes equal to zero. Yeah. Correct, na?
Correct.
Yeah. And
Just now 1 minute.
hmm.
Entropy of the system approaches a constant value as the temperature approaches absolute zero.
Temperature absolute zero matlab minus 273 degree Celsius. When it will reaches to that, the entropy will means entropy will become zero. Entropy will remain pura matlab everything will get seized. Means like no molecules, even atoms also will not move. Means like change in entropy will become zero like that. Or constant only you can say. You can say constant. Yeah. Constant means what? S2 minus S1 is equal to 0, right? So S2 is equal to S1 means entropy is going to remain constant. Yeah, correct. Proper it is.
Will they ask interviewer ask like will he ask sub questions from this?
No,
Cross
he will
questioning will be
not
done.
ask, but a change in entropy is equal to 0 is same as entropy is constant. Means S2 minus S1 equal to 0 equal S2, S1 equal to S2, right? So like that. Okay. NDT methods you read?
When the current is applied to the poles of the magnet, it will give a magnetic field around the workpiece, and at the point of the crack or flaws, the magnetic field will be of irregular shape.
Hmm.
So it means that at that point of workpiece there is a crack or flaws.
Hmm. Okay. See, in this NDT methods, no, they mostly sir will ask ultrasonic testing and magnetic crack detector test. Means so many people till now, whichever I see, so you read it properly. Means magnetic crack detector test and ultrasonic test. Okay. Then other than that, boiler accessories, huh?
Air preheater,
Which all? Can you list out the boiler accessories?
feed pump,
Feed pump.
air heater,
Huh.
economizer. I left out this the superheater.
Superheater and exhaust gas economizer means to tell fully. Okay, exhaust gas economizer, preheater, superheater, and feed pump. Yeah, correct. And another question which you can ask is, these are the important questions. Can you differentiate between the centrifugal pump and reciprocating pump?
I have not studied, sir, but I'll try to say.
Yeah, yeah.
In centrifugal pump, the centrifugal pump works on the centrifugal principle. Reciprocating pump, positive
Rotodynamic
displacement,
principle.
rotodynamic principle. Uh,
Reciprocating
positive
pump.
displacement, reciprocating pump works on positive displacement principle. In centrifugal pump, in centrifugal pump, impeller causes the vacuum to be created inside inside the casing. In reciprocating pump, the mechanical action of the piston plunger causes the suction to be created inside the casing. In a centrifugal pump, the pressure is high, and in centrifugal pump, the flow is high with the low pressure. In reciprocating pump, the flow is low and the pressure is high. In centrifugal pump, priming is required before starting the motor, before starting the pump. In reciprocating pump, priming is not required. Centrifugal pumps are used where the fluid have low viscosity. In reciprocating pump, high viscous fluids can be pumped. Centrifugal pumps are used in applications such as ballast pump, seawater circulation pump, uh, etc. In reciprocating pumps are used in applications such as sludge pump,
Hmm.
uh, sludge pump.
Yeah, this much is enough. Yeah. Uh, and the reciprocating pump, positive displacement you can say, but actually is it is a reversed piston movement principle. Okay.
Reverse piston movement.
Huh. That you can correct it. Means what is positive displacement principle?
In a positive displacement principle, when the vacuum is created inside the casing because of the pressure difference at inside the casing and the outside at the reservoir, the suction of the liquid takes place, and in a positive displacement pump, only the fixed amount of liquid gets inside the casing, and this fluid is pu- forcibly pushed towards the discharge. Is called as positive displacement pump.
No, it is positive displacement principle doesn't depend on the suction side. It is an discharge. Despite in spite of the variation in the discharge pressure, the constant flow rate of the fluid is maintained. Means if you in the
Constant flow rate.
gear pump you assume that at the discharge side there is a variation of the pressure, okay, but in spite of variation of the pressure, the same amount, means as long as the driver and follower gear is rotating, the constant amount of flow is maintained, right, throughout the pump. Means like,
Constant amount of flow.
flow is maintained. Means like at the discharge side, means the discharge flow rate is constant in spite of variation of the discharge pressure, means varying of the discharge pressure. So this is called as positive displacement principle. It is not depend on the this one, the fixed amount of
Suction
fluid
side.
at the not the suction side problem. Means a fixed amount of fluid is at the discharge side, it is sent.
Okay.
So that is the positive displacement principle. Got it, right?
Yes.
Okay, then I will give the feedback. Means like first a centrifugal pump, when what you told. Wait, why you want to join merchant navy? One non-technical question.
So my camera something problem happened, I think.
Okay, okay.
Ah.
No problem. You can just say.
Qualities that are required in a merchant navy are all I have that I have. In merchant navy, it is important that we'll have to adopt to the particular conditions, and I am best suitable for that. I have the leadership qualities which in future, if in future I can lead a good team in the ship as an engineer. I have this quality of never giving up and hard working. Whatever the situation is, I never give up. And unless it is the last, unless I have fully lost, I don't give up. And yes, sir. I
When you tell
I'm
no means like why you want to join merchant navy, you are telling everything means like I have never give up attitude. You when you tell that, give one example and justify it. Means like
okay.
you can say that you are a kabaddi player na. Means like
Uh,
whenever the team is losing, means like I still I never give up, means like that, give one example and justify it. So that will help, means like you can give your own example like that, means like anything.
okay.
So you prepare this answer. And why you want to join Anglo Eastern?
Anglo Eastern has many ships, and there is wide range of options. If I ever want to change the ship, or uh, if Anglo Eastern also provides a good placement, that is with the less placing time, and also it provides good medical facilities, and also job security is there. It also provides good economical support, which I can take care of myself and my family.
ठीक. And now I will give the feedback, means like first what you told centrifugal pump, you want to explain properly, means like it is not up to the mark, I guess. So whenever impeller rotates, no, the negative pressure is created at the eye of an impeller. Okay. So because of that, when the negative pressure is created, so the fluid is sucked from the suction side, and it will suction pipe, and it will enters into the eye of an impeller. It enters into the casing through the eye of an impeller. So when as the impeller rotates, the kinetic energy which is imparted on the fluid by the impeller is converted into the this one. No, kinetic energy is converted into the this one pressure energy, means like whenever it enters into the impeller hits,
Yes,
no, when impeller hits, the fluid will comes out through the guide vanes. There is something called as guide vanes, and it will enter
guidance.
into the casing. So casing is designed in a such a way that it is increasing the volume towards the discharge side. Means in your diagram you can say, you can see, no, first it is first the difference between the, means like inlet pipe and this one in suction pipe is there, no, this the casing is, means like increasing area towards the discharge side, no. So the kinetic energy, as the volume is increases, the pressure is decreases, like that. So so you have to
when
explain
when
it
uh,
properly, like that.
when volume increases, pressure will decrease.
Yeah, yeah.
Therefore, in centrifugal force, the pressure of the liquid discharge is less.
No, no, not like that. Wait. Never see where kinetic energy is imparted. No, kinetic imparted on the fluid, means like fluid will comes out through the guide vanes, and the discharge side, this there is increasing volume, right? So the kinetic energy imparted is converted to pressure energy, and it is lifted up. So the pressure is increases, means like kinetic energy, when a impeller hits the water, so this there will be a pressure will be increases, means like water will comes out with a more velocity, right? So like that you have to say.
Okay.
So as the fluid goes throughout out of the discharge side, the potential energy of the fluid will also increase, means like as it goes up and up, like that.
Okay.
So this is how the pressure is created at the discharge side of the pump, like that. Understood?
Yes.
Then another question, which what happens if the air is enters inside the centrifugal pump?
If air enters inside the centrifugal pump, the suction, the the quality of the suction that takes place in the centrifugal pump reduces. So as we know, the density of air is 1000 times lesser than the density of the water. It clearly shows that there won't be the vacuum won't be created inside the casings, and hence the water cannot be sucked from the reservoir. To overcome this problem, we'll have to prime the motor, prime the pump using the
Hmm.
liquid using the same liquid. What happens is when we prime the pump, the air bubbles, air particles present inside the pump will get out of the pump. So that is why priming is required.
See, when you explain the what happens if air enters inside a centrifugal pump, no, you have to tell the two things. Okay, one is whenever air enters, so air is compressible. Okay, water is incompressible. Correct. Okay, and when water is incompressible, when the air enters the pump, the veins of this impeller will be there, no, it will exerts and it will try to move the water with the help of air, but air will get compressed, means you can assume that there is a block of water and air. Okay, see here, I will once see, this is a block of air and this is a water. So water is incompressible, this is incompressible, this is compressible. When impeller hits the air, okay, so it will try to move the water, but it cannot move, instead it will get compressed. Okay, so water cannot get discharged. When this block of water moves, then the another block will go now, means towards the discharge side, but the air is incapable to push this block. So because of that,
Okay.
it cannot move the water further towards the discharge side.
Yes.
So
Okay.
this one point, this is the first point. Second point,
First point.
whenever the impeller moves, there will be initially there will be water, right? So water density is high. So because water density is high, whenever impeller moves, there you can create enough negative pressure at the eye of impeller. Okay, because water density is 1000 times the air. So whenever the water is moving inside the casing, no, so more negative pressure is created and suction can easily happen. When there is a air, so air density is 1000 times less than the water density, so no, not enough negative pressure can be created. So because of that, suction capacity of the pump will get reduced. So this is the
Yes.
second point. So these 2 points you have to tell whenever this question is asked in the interview. First point is it is incapable to move the water towards the discharge side whenever air enters inside the centrifugal pump. Second is whenever air enters, the suction capacity of the pump will get reduced. Because of that, efficiency of the pump will also get reduced eventually, and pump will dry run. Okay. Hello. 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 Can you hear? Hello? 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 Can you hear? Your mic is off. Huh.
Network issue. Network problem.
Okay. I was telling that whenever when the air is incapable to push the water outside the discharge side of the pump, no, so impeller will keeps on rotating and it will run dry. So when it will run dry, the motor windings will get damaged. So efficiency decreases, motor winding will get damaged, and third thing is it cannot push the water towards the discharge side. Fourth thing is the suction capacity of the pump will get reduced. So these are the 4 things you have to tell. Okay, understood, no? Then
Two things.
VCRS.
First one is about that compressible thing. Then second one is regarding density.
Regarding
Suction
density, no,
cannot reach.
because density is less, the suction capacity will get reduced. This is the second thing.
Then after that, what?
See, third thing is it is linked with the first thing only, because it incapable to push the water towards the discharge side, no. So impeller will keeps on rotating there itself. It will keeps on churning the water inside the pump. So the impeller will run dry because air is there, no. It will run dry and eventually the motor winding will get damaged. So this is the third thing. Fourth thing is efficiency will get reduced because suction capacity is less, no. So because of
Yes.
that, this will happen. Understood? Efficiency will get reduced. Then third question which I asked you is the VCRS, working of VCRS. So first you have to start with the compressor. Okay, whenever the saturated vapor will comes out of the evaporator. Okay, So low pressure, low temperature saturated vapor, when it will enters inside the compressor, compressor will compress it to the high pressure, high temperature superheated vapor. When you see the
Okay.
diagram of the pH value, no, with the saturated dome, you will that image has to come in the mind, means in front of you. CT will enters into saturated vapor. When saturated vapor, no, superheated vapor, sorry. When compressor is compressed, the low pressure, low temperature saturated vapor into to the superheated vapor. Then the superheated vapor will enters inside the condenser. Condenser, there will be a seawater is passed through the condenser. Because of that, the high pressure, high temperature superheated vapor is converted into the saturated liquid of the high pressure and slightly low temperature. Temperature will be slightly reduced. Okay, then the high pressure, slightly low temperature the saturated liquid enters into the into the dryer. A dryer has a silica gel. Okay, if there is any impurities like an water is present, the water is absorbed through the dryer, and then it will enters into the thermostatic expansion valve. Okay, so thermostatic expansion valve will convert the saturated liquid into saturated liquid plus vapor mixture. Okay, then that thermostatic expansion valve through the after the thermostatic expansion valve, the it will enters into the evaporator. Evaporator, what it does, it will absorbs the heat whatever is there, means like it has low pressure and low temperature saturated liquid plus vapor mixture is there, no, because temperature is less, the high temperature in the room is there, no, required space, the temperature will get reduced because coming contact into the evaporator. Then then it is converted into the saturated vapor until there has to be no mixture of the means there has to be no liquid present inside the refrigerant. Okay, that will be ensured by the sensing bulb. Okay, sensing bulb, what it does, the sensing bulb it will sense the refrigerant coming out of the evaporator, and if the temperature of the refrigerant is higher than the desired value, then with the help of the capillary tube it will controls the thermostatic expansion valve. If the temperature is very high, the orifice will be there, no, orifice will be expand more, so that more amount of low temperature refrigerant can come into the evaporator, and it will regulate the temperature to the required one. Okay, if the temperature is less, then then it will constrict the thermostatic expansion orifice will be there, no, that will the diameter will get reduced, and it can regulate the temperature. Are you getting it? Understanding, no?
One doubt. I have one doubt.
Yeah.
Before the refrigerant enters the compressor, it
Huh.
will be in dry saturated state, right?
No, saturated vapor state. Huh, dry saturated vapor state. Yes.
Dry saturated. Then after after condenser,
It
it
will
will
be in a
be
saturated liquid.
saturated liquid.
You can see the graph of the pH diagram. Okay.
Okay. Superheated vapor. pH diagram.
Understood?
Yes. After expansion wall, it will be form of saturated
Liquid plus
vapor
vapor.
liquid mixture.
Vapor plus
Ah,
liquid mixture of 80% liquid, 20% vapor. To be exact. Understood?
yes. Yes.
You have any doubt in this?
No, sir.
uh, you can ask if you have anything. Okay, feel free. And then boiler mountings, there is a 9 totally. uh, what is the function of Ventcock, you know?
Ventcock. When the charge inside the boilers are discharged,
Hmm.
it might cause depressurization inside the boiler,
Hmm.
which might cause imploding of the boiler.
Hmm.
Hence, air cocks are used to uh, re-
Avoid the implosion.
to avoid the implosion.
That much only. Correct. There is nothing wrong in that. And other than this, the Faraday's law, you told that you will study it tomorrow. And in the second law of thermodynamics, you told only half part. Okay, the energy can neither be created nor be destroyed. Only that much you told. But full law is it can be converted from one form to the another. So when you tell the second law, no, complete it properly. No, not second law. It is first law of thermodynamics. I am sorry. First law of thermodynamics. Second law, you are correct. The Kelvin, Planck, and Clausius statement you told properly. There is nothing wrong with that. Only first law of thermodynamics you complete the statement. And other than that, the centrifugal pump whatever mistakes is there, no, you rectify it. That's it. Other than that, you are telling everything properly. There is nothing wrong. Safety devices also you told, no? Oh, okay. That much only, bro. Okay.
Okay.
Thank you.
So will you give me other set of questions?
I will send it today. Okay.
Next when you will conduct?
Day after tomorrow I will conduct. Okay. Okay, bro. Bye.
So within this month I might have interview.
Thank you, bro. Bye.
Bye.